Hello everyone, today I will teach you how to solve a problem's acceleration. Acceleration is the fundamental concept of physics. Acceleration defined as the change in velocity. Velocity is speed and direction. And because of the direction, velocity is a vector. Since velocity is speed and direction, a change of velocity can be a change in speed or a change in direction. So, change in velocity is acceleration. Increase speed, decrease speed, or change direction. A great example of acceleration and speeding up is with a motorcycle. For example, like a radar. So it turns out that today we have a radar with us. So what we're going to do is we're going to find out what the 0 to 60 acceleration is for this Suzuki radar. To find acceleration, we need to set the velocity. So, to solve the problem, we have to write down. What we got the time is 4.9 seconds. The initial velocity is 0. Since it started from rest and the final velocity 60 miles per hour or 26 to 8 miles. What are we looking for? Write down what you need. The acceleration is our unknown. So now, we have to pick an equation. So we look at in our kinetics equation. The first formula for average velocity is equals distance over time. We can't use because we don't have the average velocity or the distance. Here, we could solve for the average velocity because final and initial. But this wouldn't help us because there's no acceleration. In this formula, we would be able to use, but we have to do an extra step of finding the change in velocity. Now, this formula, we have the final velocity. The initial are unknown. The acceleration and the time. So, this has two unknowns, both the distance and acceleration. So, we couldn't use it to solve in the final formula. It's also missing both acceleration and the distance. So, final velocity equals initial velocity plus 80 is the formula we will pick. So we've chosen final velocity equals initial velocity plus 80. Now, we need to substitute 26.8 miles is our final velocity. The initial is 0. The time is 49 seconds now. Solve and succeed. The acceleration is 5 meters per second squared. But if we now want to find something else, for example, like the distance, now we will write down what we need. The distance is unknown now. We go back and choose an equation. The first formula, the subdistance. However, we don't have the average velocity, so we can't use it. Now, we could use this formula to calculate the average of velocity. And go back and use the former formula. Let's try to do in one step. Here, we already have the acceleration time. And there's no distance in the formula. This formula, we know everything in it. So, there's nothing to solve for now. This last next formula has the distance what we're looking for. We know the initial velocity and the time in the acceleration. So, that will work out. We could also use this formula. However, let's go with D. Equals distance equals initial velocity T plus 1/2 at squared. So, we write down distance equals initial velocity t plus 1/2 at squared, and since the initial velocity is 0, we can't strike it out, goes to 0. So, our formula reduced to 1/2 at squared. Sub in our values acceleration and the time. And don't forget to square the time in solving. We get a distance of 74.1 meters. Don't forget to box the top up. We learned earlier that acceleration speeding up, but it's also slowing down. Let's now calculate the acceleration of the motorcycle while braking. Do you think acceleration will be a greater for speeding up or slowing down? To do this, we'll speed up the motorcycle 60 miles per hour and then we'll hit the brakes and find out the time. The time comes out to be about 3.1 seconds. So write down what you got. The time is 3.1 seconds. The initial velocity this time is 60 miles per hour. And the final velocity is 0 since we got stopped. Write down what you need. We're now looking for the acceleration, just like before. We pick an equation. Since we already did the same calculation, we know that the formula that we want, final velocity equals initial velocity plus 80 final velocity equals initial velocity plus 80, and then sub in our values. The final velocity is 0. The initial 26.8 and the time is 3.1, which give us acceleration of negative 8.6 meters per second squared. Note, acceleration does not always mean slowing down. It tells us the acceleration in the negative direction if the velocity is positive only. Then, can we say that the motorcycle is slowing down?